Okay, let's dive in. Today, we're going way beyond the chatbots you might be used to and talking about the next big thing, AI agents. And trust me, this is where AI starts to get really wild.
So we've all had a conversation with an AI. They're great for answering questions. But what happens when that AI stops just talking and starts doing? When it can actually reason, make a plan, and use real tools to accomplish a goal out in the world? That's the huge leap we're digging into today.
Right, so here's the fundamental difference, and it's all about going from passive to active. A chatbot, it's kind of like a super smart encyclopedia. It knows a ton, but only what's already printed on its pages. An AI agent, on the other hand, that's more like a detective. It can figure out what it doesn't know, and then it has tools, a web browser, a calculator, you name it, to go out and find the clues to solve the case.
So you're probably wondering, how does an AI agent actually, think? Well, it turns out the core logic is this surprisingly simple but really powerful loop. And honestly, it's going to feel pretty familiar.
It all comes down to a framework called REACT. That's short for reasoning and acting. And the whole idea is that instead of trying to solve some huge problem all at once, the agent just breaks it down. It thinks about one tiny step, takes an action, sees what happens, and then uses that result to figure out the very next step. It's problem solving piece by piece.
And this is basically that loop right here. It's a perfect three-step dance. Thought, action, observation. And I mean, isn't that pretty much exactly how we do things? You think, what do I need to do first? Then you take an action, you Google something, and then you observe the result, which feeds right into your next thought. It's this constant cycle.
Okay, check out this super simple, concrete example. An agent is asked to add two numbers. It doesn't just guess. First, the thought is, I should calculate the total. The action is to actually use its calculator tool with the numbers. And the observation? It gets the answer back, 579. Boom! Now it has a solid fact it can work with.
And this right here is the big takeaway. This REACT loop, it's what turns a passive, kind of book-smart language model into an active, street-smart problem solver. It's the thing that lets it stop just talking about the world and actually start interacting with it.
Okay, so that's the theory. It sounds pretty neat, but how are developers actually building these things in the real world? Let's pop the hood and look at the toolbox. Well, as you can probably guess, a whole universe of frameworks has just exploded onto the scene. You've got names like LangChain, Crew AI, LangGraph flying around. It's a super exciting time, but honestly, it's also kind of the Wild West right now. So, what's the ground truth? What's it really like for the developers who are using these tools day in and day out?
Well, one of the biggest headaches is just how fast everything is changing. As this developer on Reddit points out, you can start building your project with something like LangChain, and then an update comes out and the APIs have totally changed. Suddenly, what should be a simple bug fix feels like you have to rewrite the whole thing from scratch. It's like trying to build a house on an earthquake fault.
And it's not just the speed, it's the complexity. Another developer using a tool called LangGraph put it perfectly. They said it's super easy to do things the wrong way, and you won't even realize it until your agent is up and running and just starts doing weird, unpredictable stuff. These tools are incredibly powerful, but a lot of them still feel a little half-baked.
So how on earth do you deal with all that chaos? Well, developers are turning more and more to something called observability platforms. You can think of them like a debugger, but for the AI's mind. They're these specialized tools that let you see exactly what the agent was thinking, step by step, so you can pinpoint exactly where it went off the rails. They're becoming absolutely essential.
All right, so we've covered the basic building block, that think, act, observe loop, and we've seen the messy reality of developers trying to build with it. But now, what happens when you take this whole idea and you just scale it up? I mean, way up. What if you build not just one agent, but an entire town full of them?
This is Smallville. It's a virtual sandbox town created by researchers from Stanford and Google, and it's populated by 25 totally unique AI agents. And the goal of this absolutely mind-blowing experiment wasn't just to see if an AI could complete a task, it was to see if AI could simulate believable, complex human social behavior.
So let's take a look at a day in the life. This is one of the agents, John Lin. He wakes up, brushes his teeth, makes himself some breakfast. He even has a conversation with his wife and son. Now, the absolutely critical thing to get here is that none of this was scripted, not one bit. Every single action was a decision made by the agent itself in that moment.
So how in the world did they pull this off? Well, it took a much more advanced setup than that simple React loop we saw earlier. These agents had a whole architecture. They could perceive what was happening around them. store those perceptions in a long-term memory, and then do these higher-level things called reflection and planning to decide what to do next. So they don't just react, they remember, and they strategize.
And the results from the study? They were absolutely crystal clear. The researchers had real people evaluate how believable the agent's behavior was. And as you can see, the full architecture, the one with all the bells and whistles, was rated as way more believable than the versions where they took out key parts like memory or planning. Every single piece of that system was crucial.
But here is where things go from really cool to absolutely fascinating. See, the point wasn't just to create 25 convincing individuals. The real question was, if you put them all together in this town, would a believable society just emerge on its own?
And what happened was just incredible. The researchers planted a single idea in one agent. Isabella, you want to host a Valentine's Day party. That was it. From that one little seed, she started telling her friends, and the news spread totally organically from one agent to the next during their normal conversations. Pretty soon, 12 different agents knew about the party, and 5 of them actually coordinated with each other and showed up. This wasn't coded into the system. It was emergent behavior.
Wow. So, from a simple 3-step loop to a virtual town literally buzzing with social life, we've seen just how much potential AI agents have. But what does this all mean for us moving forward?
So let's just recap our journey here. We've learned that at their core, AI agents use a pretty simple think, act, observe loop. We've seen that developers are using these new, sometimes tricky frameworks to build them. And most amazingly, we've seen that when you put them together at scale, they can simulate incredibly complex social behavior.
Look, the Smallville experiment was just a simulation, right? But as these agents get more and more capable and start moving out of these virtual sandboxes and into our real world, the question isn't just about what they can do anymore. The real question is, if AI can simulate a believable community, how is it going to change the way we build our own?